The table at the right shows the number of seniors who graduated from a small college during the latter half of the last century. Data was not available for all of the years, especially those longer ago. So it gives us the year and then the number of students in that graduating class. The first thing that we want to do is make a scatter plot and describe the trends that we see in the data. Let's go ahead and start with typing this data into our calculator. We're going to stat, edit, and go ahead and pause your video for a minute. We want to type in all of our data here into L1 for years and L2 for number graduated. Once we have our data typed in, we're going to make a scatter plot. So I'm going to edit my stat plot. So second y equals, I want to make sure I have a scatter plot, so that's the first one. Right now I'm pulling data from L1 and L3. I want to make that L2, so I'm going to hit second, 2, and then I am good to press zoom 9 and make this scatter plot. When I go to sketch this, I want to make sure my x and y axis are labeled. So the x were the number of years, and the y variable was the number of graduates. I am just going to sketch here what I'm seeing. So it looks like we start with an increase. Decreases, and then a slight increase again. All right, now the next thing it wants me to do is describe the trends that we see. Because it's just talking about trends instead of association, I don't need to talk about the direction, form, and strength. Instead, I'm just going to talk about what we're noticing. So hopefully one big thing you're noticing is that there are multiple directions happening. It looks like there was an increase in the number of graduates, then a decrease, and then another increase. So I'm going to say the number of graduates increased from, and I'm going to be specific here and give the number of years. So it looks like starting at 1950, we're increasing until we get to 1970. 1970 was at 521. The next year it started to decrease. So that means right here, this last dot was at 1970. So from 1950 to 1970. I'm going to say there was a decrease from 1972 is where we start to decrease. It looks like we're decreasing until we get to, looks like 1992. So I'm going to say from 1972 to 1992. And then it looks like this last piece, this is where things start to increase again. So I'll just say the graduates increase again. From 1994 to 2000. Number 2 says, these data do not show the size of the graduating class in 1969. We want to create an appropriate model and use it to estimate the size of that class. Explain what years you used and why. So we're coming up with a model here to make a prediction in 1969. Now at this point we have said that it looks like things are increasing, decreasing, and increasing. So right now, if I'm looking for 1969, that's going to be in here. So roughly right here, put that asterisk for 1969. if I were to use all of the data that they give me, my line of best fit is going to be kind of wacky because part of it's positive, part of it's negative, part of it's positive. I don't think using all of this data is going to be a good representation of what's happening for all of these years. So if we're looking at just 1969, my guess is it would be best if we had a line that went this way. So when we go to make this model, let's use the years 1950, and we'll just use where it was increasing. So we're going to go until 1970 to create this model. This will give us a good prediction for 1969. So in our calculator, I'm going to go back to my stat edit. I am keeping 1950 to 1970. All of these other ones I am going to delete. Alright, so I just have from 1950 to 1970. Let's use just these years to create our model. So let's go to Stat, Calculate. We want a linear model, pulling data from L1 and L2, and I'm calculating. Remember that we want to write this in context, so my Y variable is number of graduates, putting a hat because that's a prediction. Looks like my slope is 16.06. Times the x variable, which is year, minus 31142.99 for my y-intercept. Alright, so far we've created a model that we think is appropriate to make a prediction for 1969. Let's go ahead and use it now to estimate the size of that class in 1969. So we're going to do that by taking 1969 and plugging it in to our model. I got 479.15. If we take a minute and look at our data, I want to make sure that this prediction makes sense. So the year 1969 would have been right in here, and 479-ish students does make sense. It's kind of right between what I had for 1968 and 1970. The last thing it wants to do is explain what years we used and why. In the very beginning, we said we were using 1950 to 1970 because it was between these years that our data was increasing. So I used 1950 to 1970 because the data follows a linear pattern. Also going to include that it was increasing in this range. Number 3 says if we wanted to project the graduating class sizes through the year 2010, what model would you use? What aspect of these data makes you cautious about your projections? So I know I'm trying to make an estimate for 2010. So looking at my data, here was the year 2000. I'm trying to go all the way to 2010. Looking at my graph here, I probably don't want to use this linear model that I've already created because I know it's not accurate after that year 1970. There is this decrease. So the model that we created in number 2 isn't going to be accurate when it comes to making predictions way over here for 2010. I probably don't want to be looking at this middle set of data because it's decreasing, and I know that that doesn't continue on in time. So instead, let's use just these points in here to make another linear model that's increasing, and then this should help me make an estimate for 2010. So for this one, I'm going to use these years here from 1994 to 2000. This is where it was increasing again. So back to calculator, we're going to stat edit. I am just going to clear these guys and type in my new data. We are creating a model, so stat calculate linear regression. Still pulling data from L1 and L2. I'm going to calculate, and it gives me my slope and y-intercept. So my new line, still predicting the number of grads. My slope is now 5.15, so a little bit lower, times the year, minus 9,852.8. Okay, so it says, what model would you use? This is our model that we're using. What aspect of these data makes you cautious about your projections? So in this case, if I were to plug in 2010 and make a prediction here, why should I be cautious about this? Well, going from 2010 is an example of extrapolation. This goes beyond my data, which I should be wary of. I don't know if for sure if this line of best fit is going to continue to be straight. We've seen already in this data that things are increasing, decreasing, and increasing again. So who's to say that in 2009 we wouldn't see another decrease? This is why that idea of extrapolating beyond your data is an issue. You want to be careful with that extrapolation. I like this example because this is more, I think, representative of what we would actually see in the real world. Typically, we will notice kind of these trends that make things look not as linear. It's okay if you see something like this to just pick certain points and make linear models throughout. So we would have a positive linear model for the beginning years, we'd have a negative linear model for these middle years to make predictions, and then I would have another positive one towards the end. But again, be careful with making any predictions beyond your actual data.